All right, everybody. The next section is buffers. This is super important when it comes to your body's ability to maintain homeostasis. All right. So a buffer is, I know it's kind of weird, but it's exactly what it sounds like. It's a buffer. And it's a little annoying, but some of you may have heard of the term before. Like I have a buffer in my bank account. Just as like a preventative kind of thing, to make sure that I don't. If a bill comes out, I don't just like go over or get overdrawn. So with that said, if you think about the body, it also has buffers. What that means is this: if there was a sudden change in pH, your body will not necessarily suffer those consequences. All right. The best way I think I can explain this is by using an image. All right. Again, this is general, so you can look into more detailed versions of this, but this is just a nice little general picture of a buffer. I also have my little slideshow. This is going to help out too. All right. So let's just play pretend here. Okay. If I have a graph, right, and let's just say I start somewhere right in the middle of this graph, right? I'm at 7. Let's say that's a 7 right in the middle. Okay. I'm neutral, right? I'm at a neutral pH. I'm happy. Here's my little middle ground, right? Everything's good. What would happen if I started to consume very acidic foods? What would happen to my blood? Right? Just like anything else you eat, it will impact your bloodstream. So if I have a whole bunch of an acidic food, my pH will start to drop. Right? As weird as it sounds, it's going to go back. I'm going to go backwards with this. It's going to start to decrease. One might assume it'll look like this. Right? So 7. Right? And then the opposite. If I have basic foods, it'll go up, right? So you're 8. It's horrible. 8, 9, right? That's the assumption. I eat food, it goes acidic or basic. Here's an issue here, though. What did we say a minute ago on the other video? It's a little annoying, sorry. All right, a minute ago on the other video. What we said was pH changes at a factor of 10. So with that said, if your body hits 6 or 8, this could mean death, right? These are your deadlines, not in like you owe paper. I mean, this is where you die, right? That's not good. You don't want to get too acidic or too basic in your blood. You can't afford that. So with that said, your body has buffers. What buffers do is they basically take the hit, and it makes it so that it's a longer process before you actually have a major change in your pH. So let's take a look at what it looks like on here. Notice a difference in the lines. Here you're seeing that it's a much more horizontal picture. So if I consume tons and tons and tons of bases, my pH is going to go up, but not by a lot. This buffer is going to maintain that middle ground. It's going to take a lot, and I mean a lot of bases in order to increase my blood alkalinity too much. Same thing with acids. It's going to take a lot of acid in order to change my blood in order to go acidic. So the point is, it makes sure that your body has this nice in-between zone so that you don't just die just because you go and drink orange juice, right? It sounds ridiculous, right? But just imagine if you didn't have these buffers, it could be an actual thing to worry about. A little dramatic, but that's the idea. However, once you hit these thresholds at the end, then it just gives in. Then it just gets very acidic or very basic. So the point is, the buffer zone elongates the amount at which your body can actually handle acids and bases. It's a buffer. So I didn't do the best job explaining this, I'm not going to lie. But I think I got the point across. If you need to rewatch the video, that works. But if not, again, there's so many other resources out there. This is just a nice short example of buffers. If you have any questions, please let me know.